Um, okay, it's almost time. People are kind of arriving, but they're dropping out again as well. So. But yeah, it's a very important session this week. Apologies also for last week. I wasn't able to do it, but I wasn't really ready, and I wasn't sure how to finish off these sessions. And having had a little bit of a thought, I came around to thinking, well, actually, this came about because of a conversation that I had through Facebook from a woman from Kenya who was involved in biochar projects there. And it made me think how much this might be relevant for all of us to think about. So that's going to be the theme of the session this week. And one of the things that jumped out at me, Andre, was, well, to everyone, is I'm just pausing for people to arrive. So, welcome everyone. Okay, welcome. I'm going to start slowly because I know there's other people arriving, and which indeed there are. There's always problems with people getting just not getting having a good enough connection. I can see Richard is dropping out. Okay, I'm going to do my best to not be distracted by people coming and going, and I'm going to start talking about biochar. And as I was just saying, this was sort of triggered by a sort of a chance conversation that I had during the week via Facebook from a woman in Kenya who is growing biochar and selling it in return for carbon credits for money. And I thought a lot about the possibilities of this being an enterprise for income generation that could sit very well with farmers networks, refugee networks, and small farmers everywhere. So we're going to start off with just a recap. Really, this is a presentation I did quite a few years ago, more than 10 years ago, just to introduce to the subject of biochar. So pardon me, those who are already familiar. And just to say, I'm not an expert by any means on this topic. I am just a teacher, and I'm just very keen to share knowledge and information and to generate discussion. So here we go. So biochar. Firstly, we're going to have a little think about what it is and how we might use it and how we might make it rather. And but let's say something big and exciting to start us off. Let's get everybody's attention. This could be a keystone technology in the fight against climate change. This is big. This is important, and I think that it's big and important for the reasons that this might be a technology that we can all adapt at whatever scale. And we need strategies and responses that a great many people can become involved in. I think those of you who know and understand about the climate problem is it's only going to get worse until we stop polluting. And so no amount of offsetting, of carbon sequestration solves the problem. If we can stop polluting, and we're very, very interested in those things, those processes, strategies that might help us remove some of the excess carbon from the atmosphere. If you don't want to think about the big picture, the global atmosphere, let's think about the local, the specific to ourselves is biochar increases food security, and it does it by helping you build stable, fertile soils that can absorb and hold water better and promotes healthy soil life, that microbiology that lives within the soil, that is everything for long-term soil stability. So this technology, these ideas need to be made accessible to everyone, to all people. And many early adopters, especially people in the permaculture movement, were very interested in in biochar when we first started talking about it. But there's many things competing for our attention, and you might be forgiven for thinking it was a little bit of a fad, but it's very much not, and very much an enormously important technology. So let's go down into the soil a moment and let's just think about what soil is, and how we interact with it a little bit. So we can see some grass, we can see some living plants, we can see some roots, we can see some dead matter, dead organic matter. We can see the sort of the mineral part of soil, and of course it's all glued together with humus, with organic matter, and very, very importantly, it provides a habitat for the soil microbes, the soil life. And let's just remind ourselves that all of that life in the soil, those beneficial organisms that we want to team up with, they all, just like us, are aerobic. They breathe in oxygen and they breathe out carbon dioxide. So to have healthy soil, it needs lots of air spaces within it and not be compacted. And let's also remind ourselves that it is this biological activity that goes on within the soils that make nutrients available to plants. This is your fertility. Biologists, ecologists talk about how ecosystems are formed of different trophic levels, energy levels. The energy that powers every ecosystem comes from the sun. And plants, through photosynthesis, convert this energy into sugars and starches and carbohydrates. And they trade these sugars and starches with fungi, with bacteria, with soil life. And in return, they begin to get access to the minerals and other nutrients that they need. So the first trophic level in an ecosystem is always photosynthesizers. The bottom layer of our energy pyramid is always the photosynthesizers. That's the plants. And plants live and die and create organic matter, which provides waste, residue, and metabolites from plants, animals, and microbes, which the other living members of the system may access. So there are nematodes that feed on the roots. There are different kinds of fungi, what we call mycorrhizal fungi. These are fungi that live in harmony, in a partnership with the roots of the plant. And there are saprophytic fungi. That's the kind that breaks down organic matter. Saprophytes feed on dead material. Mycorrhizal fungi instead trade sugar for minerals with the plant roots. And within that environment is huge numbers of bacteria. So we go into our third trophic level are those organisms that feed off and from the second trophic level. We see little mini arthropods, tiny little insects, bigger, different kinds of worms and nematodes, and things which are protozoa, includes things like amoeba, flagellates and ciliates. Huge numbers. There are actually many, many millions of varieties of organisms living in the soil in close association with the roots. And then there are those other larger predators. We're seeing bigger worms, bigger insects that feed on of those. So we don't really get to see the life in the soil until we get to the fourth and fifth trophic levels. So this is a reminder of the complexity of life that is going on within the soil, and a reminder that that complexity of life, just like us, needs air and water to be able to thrive and to flourish. So sometimes when we think we're watering the garden, we think that we're feeding the plants. We're feeding them microbes, or both. But just to try and shift your perspective, to think about you are a custodian, as an organic farmer, you're a custodian of this complex web of life. And what we also know is if we create the right conditions, the life will populate the soil and build beneficial relationships with your plants. You don't need to know the names of them all. You don't need to remember all of these different things, but you need to remember that they are there. And as an organic farmer, you are building a relationship with this life in the soil. It's a wonderful, very high resolution photo of mycorrhizal fungi. And what we can see is a little node and then strands of hyphae going off in all sorts of different directions. And this is what links plants together and allows them to communicate not just within a plant, but between different plants. And that's when we start to realize just how complex the life in the soil can be. This is a photo of a pine seedling, and we can see that it's germinating, and we can see the brown tap roots that are penetrating into the soil. What we can also see is these little white dots, these little node points. That's the mycorrhizal fungi. And look at that enormous net of hyphae, of fungal hyphae that's exploring the soil around it. And what this picture reminds us is that plants develop relationships, they fuse with fungi in the soil, and this increases the surface area of their roots systems by thousands of times. Enormous amount of surface area. And through this fungal net, plants can channel water huge distances and exchange nutrients, chemical signals, hormones, antibodies. This is the soil wide web, I think it gets called. But just think about how these things are all interconnected. Okay, pause. What has this got to do with biochar? Why am I going off on a whole tangent about soil science? Well, I'm just reminding us all of the processes, these essential processes which are going on around our plants, and to understand that the plant is slowly building and exploring relationships with these organisms in the soil. Okay, so the carbon story is we talk about how planting trees is a good thing in combating climate change. We can see that this tree here is sucking down carbon dioxide as it photosynthesizes. It's and it's taking the carbon molecule from the CO2 and building that into the structure of the tree, and it's respiring, it's releasing the oxygen molecule, and which is obviously what we depend on for our own respiration. So, according to this this graphic, that we could expect a net photosynthesis of nearly 3 tons of carbon per acre per year through the trees. And we can see, look, that 40% of that is taken up by the tree and its branches, its leaves, another 13% in its roots. Woody debris that's returned to the soil represents another percent, and a whopping 45% of that carbon ends up in the soil. Now, and obviously some of that returns as carbon dioxide as the soils also respire and return some of that carbon back to the atmosphere. What we're interested in, though, is long-term carbon sequestration, because obviously trees live and then they die. We can have fires that can be harvested for fuel, and maybe much of that carbon is still being returned to the atmosphere. So we're looking for something more than just growing trees. And there's nothing wrong with that, but perhaps we could do more. And this leads us into the biochar story a little bit. What we know, and there is increasing amounts of research now, is that when these residues of carbon, which might be produced through, well, we'll talk about how we produce biochar in a moment, but is, let's just say, and the addition of biochar to soils increases their porosity. It seems to increase their ability to allow water in and to hold on to that water as well. And there's something else going on as well, because we're looking on this one side without a carbon addition, and clearly the soil is weaker and drier and breaking down. And on the right hand side, where we're seeing there have been a carbon addition, we're seeing lusher, richer vegetation. We can talk about the history of farming, land clearances, and how human activity has been responsible for unleashing huge amounts of carbon into the atmosphere. Look, these trees, maybe 1,500 years old. I think this is in Tasmania or Australia, and they're being processed to make floorboards for houses. We've converted huge ecosystems that have been long-term stable stores of carbon over millennia, or even thousands of years, millions of years, and we're releasing that carbon back into the atmosphere. There's some figures. This is from the IPCC going back to the 90s. So this is quite an old graphic, but if we just look at the look at the trees. We've got our forests, and we can see that according to these numbers, that as a forest grows and matures, it sucks down carbon into the trees through its roots into the soils. As those trees age and stabilize and eventually shed their leaves and twigs, is that much of that carbon is returned to the atmosphere. So we see a net sequestration, according to this graphic, of 6 billion tons. And we're pumping out about 45 billion tons of carbon right now from industrial. The same thing happens in the sea, and essentially there's a net sequestration of carbon in the oceans as well. Unfortunately, so 23 gigatons emissions here. This is going back to the 1990s. We now know that in the 2020s we're at 40 gigatons, maybe 45 billion tons of carbon is coming from our use of fossil fuels. So however well the planetary systems, land-based and aquatic systems have been good at stabilizing and sucking down carbon, building up huge reserves over time in soils, in carbon, in the fossil fuels, our burning of those fossil fuels is way faster than what the Earth system can endure. Okay, so this book came out, I think, in 2010, so it's already 14 years old. written by Albert Bates, who is a United States ecologist and polymath. Actually, very, very interesting guy. And this book kind of blew my mind when I read it, and it really opened me up to the whole topic of what this really means. And the story that Albert tells us begins in the Amazon rainforest. And as you know, we tend to regard the Amazon rainforest as a natural system, as something that's just evolved all by itself. There's very, very low population in the Amazon because it actually has very poor soils. They're not the kind of soils that you can farm effectively. What Albert suggests through his book, and now much more research is coming out in support of this, is actually large part of the Amazon rainforest 500 years ago, going back into the mists of time, was cultivated. We could even say that it was man-made. Where parts of the forest have been cleared, they started to find black, fertile soils, very rich in carbon. These are not the kinds of soils that form under a rainforest. And it was a slow dawning realization that we're seeing the ancient evidence of farming systems that predated the Columbus, and the arrival of the European settlers to South America. We might be just getting an insight that is telling us that those early Amazonian farmers may have been the most sophisticated farmers that the world has ever seen, because you can't farm the soils under rainforests. They'd figured out something that no one else seems to have known about. So within Albert's research, what he was saying is you can see these browny red soils are very, very low in nutrient. But there's profiles of the soil meters deep of this black, what they call terra preta, black earth. And when you look at that black earth under a microscope, it's absolutely full of shards of charcoal. They also found many, many pottery fragments. And they started asking the question, how did this come about? What was this done deliberately? Was this done knowingly? Was it accidental? Many, many questions. But slowly, the picture that's emerging is this was a deliberate, managed strategy that maybe went on for certainly, maybe thousands of years, of introducing the residues of pyrolyzed biomass, and I'll explain what we mean by that as we go forward, as a soil amendment. And this was something that was done by traditional people over thousands of years. They could do it, we could do it. We can explore these ideas. We can explore how to build carbon-rich, black, fertile soils. Okay, so here's the thing. Here's something at the heart of it. And we need to think a bit about how wood burns, about combustion. So let's just do some very, very basic physics here and think about, here's a piece of wood fuel. And when wood burns, what happens? Actually, you think about it like when we light a match. The spark, the flame, is created by a chemical reaction in the head of the match, which creates heat. That heat heats up the stick of the match, and the match then gives off volatile gases and tars, hydrogen, methane, and volatile oils that burn. So they're like creosote and things like that. And so there's two stages to the combustion of wood. There is the off-gassing of these very volatile gases, which when mixed with air, burn at a very high temperature, burn at 550 degrees centigrade. And the second part of the combustion is when the char, or the charcoal that's left behind, when that is combusted. So biochar is this. We heat up the fuel so that it releases these volatile gases, but we deprive the fuel itself of enough oxygen so it can't burn. So, and the residue that's left behind, if we've done a good job, if we've made good biochar, is pure, 100% pure carbon. And we've got that in a very stable form. So the byproduct of making biochar is we get a lot of heat. We get heat from the combustion, and we get gases, and we could call it wood gas or synthetic gas, which also could be captured and condensed and used as a fuel. It could be burned to make heat, and it could be burned to make electricity. And what are we going to do with the char? That's the bit that we're kind of interested in, specifically in this. Now, when I say charcoal, look, there's nice wood gas burning. When I say charcoal, people usually think of lump wood charcoal, the kind of thing that you use for cooking. And often that's when you handle it, it's very, very dirty. It can still be a bit oily. And that's because maybe it hasn't been thoroughly pyrolyzed. There's still some oily residues in it. But it becomes biochar. Firstly is we can make biochar out of anything that once has lived. And when we want charcoal for cooking, we want nice big sort of lumps or briquettes so we get a nice fire. When we're using biochar as a soil amendment, we want it as a dust. We want it in small particles. So when we say charcoal, think of big lumps of pyrolyzed matter which we might use for cooking. When we say biochar, think more of a dust, think more of a small particle material that we are going to charge up with microbes, with beneficial microbes, and we're going to use it as a soil amendment. That's the difference between charcoal and biochar. So wood gas burns with a nice, bright, clean orange and yellow flame. No blues and greens, no other fun colors in it. And if you're seeing that in the process, then you know that you're producing the wood gas. So when we started out making this, there's lots of different methods to make it, and we wanted to just do it in a very small scale to understand the process, understand the physics of it. So this is a thing made out of a couple of different food cans, and you can see little holes drilled to control and regulate the airflow. You can imagine bigger versions of that. So here's a drum. It's been filled with dry wood. We're going to seal that into that drum, and we're going to heat it up. And the first thing that's going to come out of that is any remaining water vapor. Any remaining humidity in the wood will come out as steam. So imagine we close off our tin, whether it's a baked bean can or whether it's a big steel drum, and we close it off, we add some heat, and then wherever there's an outlet on that can, then there's firstly going to come steam. To make good biochar, we want our feedstock to be as dry as possible. So if we use narrow diameter wood material, agricultural residues, we dry them in the sun. We get them as dry as we can, because then we only have to use a little bit of energy to drive out the remaining moisture. Once that's happened, and we keep adding heat, then eventually that will start to yield the wood gas, and we can burn that wood gas and use the heat from that burning that wood gas to drive the process forward. So something which we might call a retort kiln. We can get into the details of all of this, but I don't want to get lost in the detail. I want people to understand the absolute, the core idea of this. So, okay, why all of this fuss about biochar? Well, when we look at these little pieces of charcoal dust, and we look at it under a scanning electron microscope, so this is 30 microns. It's absolutely tiny. And what we're seeing is it's shot through with holes, with air channels. Let's think about biochar as a city for potentially for soil microbes. Think about how much surface area there is there, and think about the ability of that to hold. Whoops. I like to think of this, we're creating like a New York City for soil microbes, or like a coral reef within the soil. These, these little holes. So I think I've been told a teaspoon of biochar might have a surface area of 2 or 3 acres. Vast amount. So, and in permaculture, we're interested in edges. We're interested in creating interface where different things can come together and interact with each other. So by adding biochar to your soil, you're essentially increasing the surface area, increasing the porosity, and creating habitat for all of those essential microbes that we talked about earlier on. Now, perhaps if we got time, we could come back and look at this graph, but really it's exploring the optimum temperatures to make your biochar. And look how the surface area, as we go, we get up to about 450, 500 degrees Celsius, which is the temperature that wood gas burns at. Then look, the amount of surface area of our biochar just leaps up. And let's look at our scale here. It's almost at 0 at the bottom, and then it's jumped up to a value of 350 in its surface area, whatever that it's calibrated at. But we're seeing a massive multiplication of surface area. And here's a few pics of us. This is us learning how to make it in the early days, 10, 12 years ago. We moved on from baked bean cans to big old oil barrels, and we worked out different ways to get the wood gases to come off. And essentially in this, we're sacrificing some of the wood. There's one container, it's fitted inside another container. And the container in the middle is the one we're making biochar from. And the container on the outside is the material which we're burning to create the heat to start the reaction. And you can see we've got a lovely wood gas flame coming out the top there. Now, this was us learning how to make it. We instantly realized there's a lot of heat energy there coming out the top, and that could be used. Those gases could either be siphoned off and contained, or we could use that heat to dry the feedstock for the next batch that we were producing, or we could send it into a turbine and make electricity from it. Remember, we're creating something of incredible high value, we're releasing a lot of energy, and we're doing it from what actually could be just agricultural residues, the stuff that we do, maize cobs, nutshells, groundnut shells, literally anything. So look, then we tried insulating the barrel, the container to increase our efficiency, and you can see there the whole thing's glowing hot, releasing an enormous amount of heat. Then we started trying to working on bigger batches. So here's an oil barrel that we're fitted inside this big pressure vessel, and and on we go, So I'm just showing these methods to go. There's ways to do this, and what eventually we got to, and without going into too much details, but ultimately, when we started making it on the farm where I work, is we realized that it was a big it was a real difficulty moving around this kind of equipment. We needed a trailer and a car to tow it, and the field was really wet because it was winter, and we couldn't we couldn't drive on the land. And and our challenge was either you're going to move the kiln to the where the feedstock is, or you're going to have to move the feedstock to the kiln. Either of that involves having equipment and handling and quite a lot of labor. So what we've evolved to doing is we've learned how to make it on a bonfire. So there are ways in which you can make very good biochar just in a shallow pit in the ground. So actually, all these clever gizmos aren't necessarily required, but it really helped us understand the process and start making it. What you can't quite see is this stove here, this stainless steel stove here, is from India, and it's a cooking appliance that uses the wood gas for cooking. Now we are boiling some water, and it retains the char part of the combustion, which for biochar. So lots and lots and lots of invention and playing and creativity to go into finding methods in which how we could produce batches of biochar at different scales, and asking the question, can we incorporate it even into our sort of day-to-day lives? Look, here's biochar made from grasses that have been just compressed into a tablet and then pyrolyzed. And you can imagine you might be able to design and build the pyrolysis processes to suit whatever feedstock it is that you're working with. And what we find is it works best if you've got lots of material that's about the same sort of diameter, so the same kind of size. And as a soil amendment, it seems to have, again, lots of research to be done. I'm not just saying this is a one hit cures all your problems, but there's a lot of evidence to suggest how biochar can be very, very beneficial when added into growing systems. Here's grass trials, and you can see clearly there's visible benefits. Now, I'm not going to claim I know all the answers to all of this, but it's we're onto something. We know that it increases water retention. It seems to improve nutrient availability, increases microbiotic activity, and we end up with healthier plants, and potentially hugely improved yields as well. So what's not to like, and lots to think about there. So there's my quick introduction. Biochar is organic material that's been pyrolyzed. It's been heated up in an environment where the oxygen is restricted so that it cannot burn, but instead it yields these volatile gases, which when mixed with air burn, and the fuel itself actually becomes a crystalline form of carbon that's very, very stable, and when introduced into the soil, stays there for thousands of years, potentially for very long periods. Okay. I went on to the website of the International Biochar Initiative, and this diagram kind of summarizes a lot of what I'd have just said, and I thought we might explore that a little bit. So, feedstocks, that's the material we're going to make our biochar out of. So it says here, biochar production processes utilize cellulosic biomass, such as wood chips, corn stover, rice, peanut hulls, rice hulls, tree bark, paper bill sludge, animal manure, most urban, agricultural, and forestry biomass residues, all sorts of things. Anything that once grown could be used as biochar. So when it comes, our carbon source, manure, organic waste, biograss, bioenergy crops. Think of those things that grow very, very quickly. Those nitrogen fixing, fast growing trees, grasses, willows, things like that. Vetiver, many, many different plants. Bamboo is a very, very good one. And it was the bamboo that got me really thinking actually about that, because we've seen how some of our trainees have been very successful at growing bamboo in some quite difficult areas. So the feedstocks come into a pyrolysis chamber. If you're small scale, you could be doing this in a pit in the ground on your farm. You don't need necessarily huge structures, but let's just imagine this more as a function, as a process. So within a controlled system, we're going to pyrolyze our biomass. That's going to give off biofuels. That's the wood gas, bio oil, hydrogen, methane. Some of that is then combusted to create the heat to drive the pyrolysis process. So once you've started it off, you're just running on the gas that you're generating. So in this diagram, look, 50% of that is biochar, which is returned to the soil, back to where it came from. And that's going to then help grow the feedstock plants that are going to come into the system. And then we've got 50% available here to use in, you can run cars on biogas. It could be combusted for energy to make electricity. You can use the oils and other production things, or it can go to industry. So the outputs, beside the biochar, bioenergy is also produced in the form of either synthetic gas, syngas, or bio-oils, which can be used to produce heat, power, or combined heat and power. When I spoke to her name on Facebook was Biochar Sharon, and she's a Kenyan farmer, and she told me that if you can produce good quality biochar and you send a sample for testing to the testing laboratory, and they fill out this certificate, say who's produced it, and it tests the quality of your biochar for moisture, organic carbon, ash, nitrogen. It tests the pH, electrical conductivity, particle size, and also tests it to make sure that it's not contaminated with heavy metals and things that could be problematic. And from that, then you get a certification. Now, I don't know anything more about this than what I've just looked into, but there are clearly people doing this and having a degree of success with that. And if so, this captured carbon represents a saleable commodity which can be counted as carbon credits. And the world is trying to develop a market for carbon credits, so that we can reward farmers and producers who are taking carbon from the atmosphere and returning it to the soil. So there's a world of potentials there for us to explore. I'm going to pause at this point. We could go into a bit more detail. I've downloaded the annual report from the International Biochar Initiative, so we could look at that. But love to hear any questions and any thoughts from anyone. Yeah. Is anybody who some of you out there, I think, have experience with this and probably know a lot more than I do. I wanted to get the topic rolling, and I'm really interested to think about opportunities that might be there for income generation for small farmers, the very many refugee settlements that there are in Uganda. Last week, Stella travelled back and Vicky travelled back to West Margie, to West Nile, to Margie 3 refugee settlement, where we saw huge bamboo thickets which have been cultivated from plants that we supplied 5 years ago. And so that was very exciting to see that possibility and to think about how we might be able to develop income streams, certain by harvesting and polarizing some of that bamboo, and start to participate very much in the carbon economy ourselves. Shanaz, thank you for your question. Please, yeah, please turn your mic on.
Sorry, the question was from Dij, who's also listening to your lecture.
Sure.
Steve, can you use things like, twisted cardboard and, rolled newspapers that you platted up, etc., so that they have some sort of compaction, so when they burn down, they're not as, obviously if you burn newspaper, it's very fly away. So, is that something that you could use as well within?
But potentially, yes. And what we saw there in the presentation was grass pellets. So grasses that have been compacted into little briquettes.
Yes.
I think you'd need to design a kiln that for processing the particular feedstock that you were working with. And I don't see why you couldn't compress paper waste and process it, for sure.
Yeah.
It
Just
might have a higher value use though, but and they're particularly interested in biochar produced from agricultural residues and from plants that have been grown specifically as biomass crops.
Right.
But yeah,
okay,
sure.
Understand.
Yeah.
Okay, interesting.
Thank you.
Thank you.
Welcome. Caroline.
Good day, everybody. My question is, I've actually been thinking of exploring this biochar and probably making charcoal briquettes, because the She Generators Perma Hub is right next to Jaggery factory. So we have a lot of sugarcane waste, Sometimes it's a whole mountain full. And we try to remove it, put it in the farms, but it's still a lot. I think I would need some help to be able to probably make this into biochar so that it can be more useful, or turn it into briquettes, so that we can use it for fuel, for cooking.
I would say, so that's a massive, huge opportunity. Wherever you see a very large pile of one thing, you are looking at a huge opportunity. So things like rice husks, anyway, coffee, parchment, depending on what they're, or, sugarcane waste, residues, let's not call it waste, it's not waste. You might find, though, Caroline, that making that into biochar and selling it on for carbon credits and using it as a soil amendment might be hugely more valuable than burning it. So these are ideas we want to explore. We're very interested in. Thank you for that question. That's a very good observation that you've made. Hello, is that Armstrong? Am I saying? Please welcome your contribution.
Yeah, hello. How are you? Sorry, my name is Mary, but I work together with Armstrong.
Okay.
So I'm also in Kenya, and right now it's farming season in Eldoret. And I've noticed that most of the maize plantation go to waste, and this is something that, coming across your platform, I've gotten a bit more knowledge about it, and I'd be interested in talking more about biochar because there are acres and acres of this that can be turned into biochar, but without the knowledge, we might be making mistakes without knowing what it is.
Sure. So that's a very good observation, and you're absolutely right. There's an enormous opportunity there. Absolutely. Especially where there's a lot of the same thing, then we can devise a production process that just speaks to that opportunity. And you can start by I mean, we could talk about some more detail, but so the permaculture principle
Yeah,
is start small and experiment. And
yes.
you could take some of those residues and just try. I mean, I could explain a little bit maybe about how to do it on a bonfire. I haven't got
Yeah.
my props for that.
Yeah, it's okay. But from your presentation about it, I've
Yeah.
actually gotten a bit of an idea of the things that I might need and do a bit more research so that when I'm getting the materials to get the moisture out of the
Yes.
residue, I might be able to implement that. And you said there's testing to see,
I was told there
take
is a laboratory in Nairobi that we can send things to. I haven't done that yet. I only just heard about it, but there are people in Kenya doing this for sure.
okay, I appreciate that.
That's great. Shanaz, is that another hand up from you, or is that a legacy?
Sorry, it's a legacy, Steve. I
That's
beg your
okay.
pardon.
No worries, no worries.
I don't know how to take it down.
Okay.
Sorry.
Any other questions?
Mine, it is not a question, but it's to congratulate Steve for every day, the day by day that you teach this group. I feel I'm comfortable with the topic, and this is like it is a wonderful topic today, because if it is a news, it is a new topic for those who didn't understand about this topic of today. Uh, Congratulations, and it is still in need for us, because it is very interesting. Thank you.
Yeah. Thank you, Andre. Thank you very much for that. And maybe just to carry on, what I haven't, perhaps not to labour the point, but is what we're not going to do is to make our biochar and grade it down into small particles and then just add it to the soil. That's not what we do. What we can do with it, though, is we can add it to our composting processes. We can soak it in water. We can make compost teas, and we can, if you like, charge it up with beneficial microbes, with the nutrients that we want to use. Now, there's a lot of research that's shown, even in non-organic farming, where people are using fertilizers, is the presence of biochar in the soils makes the fertilizers stick around longer. Now, we're not promoting that at all, but it's interesting. So, and what we probably think is that the farmers in the Amazon were very adept and experienced at using biochar, and they knew how to inoculate it with certain things to create desired outcomes as well. So it's probably a very, very interesting, complicated process there to be explored of these different treatments. But I want to
Yeah,
go on.
sorry.
Yeah.
Yeah, I wanted also to talk for those who are in Kenya. It can be very important for us to collaborate, to work together, because we are all in Kenya as partners. Maybe we can share knowledge and ideas about all topics, all permaculture, because permaculture is a very big project. So that was my suggestion. If it is possible, we can organize ourselves, so that maybe we can share something good. Thank you.
Absolutely, yes. And we need to collaborate. We need to build teams. We need to understand that we're all actually working together on these things. Now, I had a question early from someone through Facebook who wanted to know about chicken farming, and he wanted to do chicken farming. And I said, well, we're going to talk about biochar later. You need to come along. And there is experience now coming that if you grind up biochar and you introduce it into the food of your animals, your chickens, your cows, your goats, it increases the efficiency of their digestion, because not only are microbes essential in soil and soil function, microbes are also essential in our digestive tract. And introducing carbon particles into food systems helps animals digest their food. You get a greater protein conversion rate from the feed to meat. It also gives you healthier animals. So and then obviously that biochar is going to pass it, and they're not going to digest it, so it's going to pass through their digestive tract. When it comes out the other end, it's now bio-inoculated with the kinds of microbes that we need to promote fertile soil. It's also going to adsorb and bind onto the ammonia and nitrogen that is in the animal droppings, and that reduces the smell, the odor, and it also stops that nitrogen from escaping out of the system. So there's many benefits of integrating this into animal husbandry. Yes, please, your question. Thank you.
I see in the comments something that I also wanted to answer. Ask, how can you differentiate between charcoal and biochar?
That's the question that everybody asks, isn't it? And essentially, they're the same thing. But biochar has been made more deliberately to dry at a hotter temperature. You want to get it to about 500 degrees centigrade. And that drives off all the volatile oils and gas and materials, so that what you're left with is pure carbon. So the difference is primarily is the intended end use. Charcoal we're going to use for cooking. Biochar we're going to use for the soil. Charcoal is in lumps, nice big lumps or briquettes. Biochar is more like a dust or small particles, 2 millimeters to dust, shall we say. So really the difference is that. I hope that answers the question. It's the number one question that people ask. They get a little confused.
Yeah.
Essentially, chemically,
more
they're the same
question.
thing.
One more question. I wanted to find out, once you've taken it through pyrolysis, how
Yes.
do you get this energy that is released from it so that you can turn it into energy, electricity?
Yes.
Like,
Well,
is there
so
something that
yeah, another
is that happening?
really good question. So to make it to the pyrolysis process involves heat. So we're going to burn some twigs or something to start that process off. When the gas starts to be released, we then use the heat of that gas to drive the pyrolysis process further forward. But we could use that to drive a turbine and to make electricity. Or we could harness that heat to dry off the feedstocks for the next batch that we were going to make. So obviously, if we were going to make electricity, we'd need a turbine, we'd need to construct something. But I want you to see that that potential is there right from the word go. So if we're making it in a field, in a pit in the ground, it's very hard to harvest all of that energy. Basically, a lot of it gets wasted. But with slightly more complex systems, we can, and it is possible. And but that maybe involves having a bigger kind of kiln, and that means then you've got to transport your residues to the kiln. Now, the example that Caroline gave us about the jaggery factory, the sugarcane factory, is they're already transporting that sugarcane to the factory. So we've got a lot of one material in one place. So there, in that situation, we might want to build a nice big kiln and specifically for that use. And we might be able to do energy capture as well from that. So I would advise you to start small, experiment, make batches of it, add it to your compost, try feeding it to your animals, and adding that into your growing systems. That's a great place to start, and you'll quickly learn if you observe and ask questions. Any other questions or comments? So welcome. Okay, this is the okay. Thank you, Laura. This is the annual report from the International Biochar Initiative, IBI. They have a website, there's information on there which is interesting to look at. And there's also a USBI, which is the United States Biochar Initiative. It says, highlights of this report. This report is focused on 5 key findings from 1,000+ respondents. Biochar continues to lead the way in delivering durable carbon dioxide removal with global production of at least 350,000 metric tons of biochar in 2023. So revenues from biochar producers, distributors, value-added producers and equipment manufacturers exceeded $600 million in 2023. Carbon dioxide removal markets for biochar carbon credits are thriving, but a majority of biochar producers do not generate biochar carbon removal credits at the moment. Markets for biochar are growing, but developing high-quality markets for physical biochar is a leading obstacle to further growth in the industry. So we can sell biochar for carbon credits, but there's more development needed to explore other markets for the product. Within and between global regions, biochar producers use a wide range of production technologies and business models, building an industry that works for all scales and all models is key. So don't be put off. Even if you're just a one-man band, you can be part of this global market. The industry is expecting biochar organizations to focus on developing end-use markets for standards of physical biochar, advocating for biochar in the carbon dioxide removal space, and supporting biochar companies to improve access to capital and grants to develop their activities. Countries represented. I looked at this map of the world. Countries represented in the International Biochar Institute include Ethiopia, Kenya, Uganda, DRC, Burundi, Zambia, Malawi, Zimbabwe, South Africa, Namibia. So I don't know why Tanzania, Mozambique aren't part of that, or Angola, but the rest are. So we're seeing here the global biochar production in 2021 was at about 100,000 metric tons per year. And in 2023, that's up to 350. This is growing. And look, big chunk of that, 50% of that market almost is North America. We're seeing some from Europe, Asia, Africa is the yellow. So there's a huge scope for growth there in Africa. Economic value. Key drivers and benefits of biochar. So when asked, What do you believe are the primary factors driving the growth of the biochar industry in your country? People said, there is a growing awareness of biochar. We're interested in the carbon credits. There's an increasing demand coming from the agricultural sector. What's the third one? There's improved biochar products are available. There are some government incentives and other demands as well. So we can see that most of it is it's like this shifting awareness, and it's linking to carbon credits. And then this realization that it's so used in agriculture, farming, and gardening. What's holding biochar uptake back? Well, there's still a low awareness relatively. We need to really promote this and educate people about it. There isn't enough demand still in the market, was a comment. And okay, Caroline just saying she had to go. Okay, Caroline, bye-bye. Thank you for coming. And so on and so forth. So it's interesting. So this is about selling BCR, biochar carbon recovery credits, biomass carbon recovery credits, in the voluntary carbon market. Is reported as the second largest growth driver for the biochar industry. However, 58% of surveyed producers, representing over 50% of global production, do not report any income from carbon credits. This result is a contrast to the very high credibility biochar carbon credits hold among the carbon industry respondents. So it's very highly regarded as a tool for reducing carbon in the atmosphere, but people haven't yet really begun to access those markets. Now, this is the journey, I think, collectively that we need to get onto. So the markets for physical biochar is 70% into agriculture, 28% horticulture. I said it doesn't actually. Markets for biochar are growing, but developing high-quality markets for physical biochar is a leading obstacle to growth. Respondents confirm that agriculture-centric biochar markets, including crops, horticultural, livestock feed, and manure management, remain the top uses for biochar, followed by soil remediation, water filtration, and forestry. Coming up behind these are burgeoning non-soil or agricultural uses, notably in concrete and other industrial materials. So are you getting a sense of how versatile this material is? You can include it in building, in housing. If you put a lime render on a building with biochar within it, it actually filters the air in your building because it's so porous. There's many ways in which we can use this, and yeah, super exciting. Anyway, I'm not going to go. So the priorities for future growth, this is from their conference, is to develop end-use markets for biochar. So we need more opportunities to sell it. We need to develop standards and specifications so we know that we're making biochar of a good standard. And we need to advocate for biochar in carbon dioxide removal in that market. And okay, Andrew's going. Andre is going because his battery's going. Okay. Let me stop that. And okay, we've got about 20 minutes left. If anyone has questions, comments, feedback. Laura, I think you're back in the room. We always look forward to your comments. Anyone else? Richard, are you still there? We'd love to hear from you. Any comments or questions, please? Yeah.
Yes, I do. Well, I would like to start by saying what I have learned from today's session. Biochar is actually a new topic to my ears, and I'm glad that I've been able to hear about it today and get to know and learn and hear from different people and their views. I've learned that it's a sustainable alternative. It burns longer and higher, so it can actually help here in Uganda. I've also learned that it is an income generative opportunity. Then I would like to say and thanks Steve and the entire Sector 39 for the sessions that we've had, the 6 sessions that we have had. Well, beginning this, Steve told me that we are going to have permaculture and leadership, and I'm like, how do these two really come hand in hand? I was so ignorant about it. But now that we have covered so much about it, I can finally say that permaculture and leadership may actually seem like unrelated concepts, but they have a powerful connection. Permaculture, a holistic approach to sustainable living, can inform and enhance leadership practices. With what we have learned from all the sessions, that's just the youth engagement, the survey observation, the funding, the fossil fuel sector, and how it has actually pushed people to more than they can adapt, the how to have an intentional mindset, how it is all interlinked to climate change. I believe that by enhancing permaculture principles, leaders like we can actually cultivate a more sustainable, inclusive, and regenerative approach to leadership, positively impacting our lives and the world at large. Therefore, I'm really grateful to you, Steve. When we began this, I had no idea of how much I would actually gain. But as we finish this, I want to thank everyone, the entire Sector 39, for involving and sharing different opportunities and messages. Thank you.
Thank you, Laura. Thank you for your thoughts. You're a very good summarizer and pulling out the salient points.
Hello, Steve.
Yeah, Richard.
This is Richard. Yes. I've been having problem with my system. Network was up and down. At a certain point, I had to restart my computer. But nevertheless, I was with you right from the beginning of the show. Well, I'm not very new to from Biochar, because I remember we covered it during our training at the first and second PDC in Kamuli. So I'm with you. Actually, yes, the challenge with me has been that issue of using Biochar for carbon credits. Because I have been trying to look for opportunity for actually benefiting from the carbon credit business. And so I think I will take it further from here to see how I could be able to enter the market of biochar for carbon credits, because I've already done several practices on how to make biochar. Currently, I have about 120 stools, or how do you call it, plants of bamboo, which is also a very good material for making biochar. And hopefully, I should be able to have some benefits from the carbon credit market. It has been nice seeing you after I don't know how many years. And I'm happy to see you. Well, concerning my trip to Germany, it is going to be on 18th of July up to 27th of July. Then I'll come back to Uganda. Thank you.
Okay. Thank you so much for that, Richard, and lovely to hear from you. And yeah, happy memories from before.
Yeah. Hi, I actually wanted to add something up. What Laura said actually aligns with the things that we work on in our company, because we're also having a summit in Eldoret that is mostly focused on agriculture and tourism and health, education, sports, a lot of things, yeah. So we're coming from a point of we need to stop having foreign aid and come to foreign direct investments where we can educate our people who are here in Africa on how to implement all these new technologies of change and also environmentally conscious processes in agriculture and how they do things, building and all that, which is going to be happening in Eldoret in Kenya in June from 7 to 8. So now that I've even gotten to learn more about biochar, I'll do more research on it so that we can even add more on it. So I'd like to consult with you later about it, if you're available.
Absolutely, and you're very welcome. And it's a huge topic with massive potentials. And what's so great is it's something we can all participate in at whatever scale. So this is all really good news. Godfrey, sir, I see you. Would you like to contribute? It'd be nice to hear your voice. Or have I put you on the spot? You have to unmute.
I am really grateful for always attending you, Papa, in our local language here in Eastern Uganda. And another person will call you Papa, because why I call you Papa is you mentored me. And I remember when I just joined a PDC in 2017 in Kamuli, that's Malam Center. My colleague who has just spoken about Kamuli. I think we were there 2017. We are old and we are good
Oh,
friend.
nice. Okay.
Yeah, so I'm really, I also add on your voice that is really, if I did not attain a PDC in 2017, my eyes would not be open as far as the global, nowadays it's no longer called global warming, but it's global heating, because it is becoming too much. It takes, I was doing a research on how best can permaculture be embedded in our education system in Uganda, especially, such that it becomes like a compulsory subject, if possible, or even if somebody may not take it as a career in the future, but when he or she has knowledge about permaculture, and my dream, my prayer, to be on through your guidance and through permaculture of Britain, I've been talking to Gerard how best we can make permaculture session of Uganda, and this one becomes like a national issue, not just a community or individual issue. It is through that kind of platform that we can have our voices being heard by leaders in the right from the grassroots up to the higher level of leadership, the government officials. So Steve John, when we talk about biochar, I'm really grateful. And I remember immediately after we had that PDC in Kamuli, I came back and I engaged the community school, the government aided school, and I imparted knowledge with our children in the UPE, Universal Primary Second and Primary School, and the community, the PTSM's leadership of that PTA is Parents Teachers Association of that community, and they really loved. And I want to say there has been a tremendous change in that school. Before, it wasn't like the trees were not growing that community and that school compound. And I think I'll take a peek of that community, of that community school, and change you how and show you how greatly the school environment is looking like. And I really thank you for that. I believe opportunities come, I would really be glad to upgrade in my permaculture. I was doing some research. Is there a course in permaculture where I saw an international diploma in permaculture design? I
Godfrey.
really, yes, please.
Godfrey.
Yes.
Okay, let me engage you in that you're saying if it can be made part of the curriculum. Something
Yes.
that would be better is if permacultural centers were established where people from the community can come and learn on
Yes.
these different methods of farming, so that it's not
Okay.
only students from school, but also people who are, you find the homeless children, the people who don't
Yes.
have the money to get to school. And there's a center where they can learn these skills on how, and they get training
Wow,
on
wow,
how
wow.
to implement this
That,
skills into the community and all that. So if there are
that,
centers that can be built in Africa that can help,
yes.
that can
Yeah.
help empower them with the
Yes.
knowledge to do all this.
True, true. That is so interesting, actually. So, Steve and the colleagues I'm really grateful, and I would really reading through permaculture is the way to go. And I was thinking a lot of how to upgrade and to go on and do a lot of research and practicing whatever we put in to get through the training. Thank you very much, Steve, and all the colleagues who have been in this session. Thank you.
Thank you, Godfrey, and thank you everyone for your comments. I mean, Godfrey, just to say that last week Stella and Vicky went back to West Nile to see the trainees from 2018, and they've had a massive impact, absolutely off the scale. And this is what really made me think. One of
Wow.
the things, we brought them bamboo plants, which have grown into almost forests. I mean, thickets. And the vegetars and things we brought have really been successful. They're using them a lot in building and construction and fences and so forth. And that was what
Wow.
made me think is there's a lot of people up there and there's a lot of space. And if we could perhaps, if the bamboo's doing really well, is there's a great opportunity there for income generation. Thank you, Shanaz.
Thank you.
Welcome. Thank you. She's just sending her greetings. So I think this is the beginning of something, and as you say, we work with global heating. It's getting into a crisis. CO2 levels in the atmosphere are the highest they've ever been today, or wherever it is. I forget the number. It's just it's ever so worrying. We're going to understand. What we have to understand is whatever responses that we have, we're going to have to be able to scale them up. So I'm really interested in things that a great many people could be engaged in, and I think this is really one of them. And it could be linked to income and community development and food growing and animal husbandry all at the same time.
True.
Yeah.
Thank you.
Okay. Is any other final comments or questions? Otherwise, I'm going to close the session and say thank you, everybody.
Okay, I would like to appreciate you, Mr. Stevens, for engaging us and giving us more knowledge and bringing awareness about this topic, because it's a very interesting one. So, and I'd also like to ask, how are we able to get in contact? Because I'd love to talk to everyone that I've met today who has talked and has changed their views, because I feel like working together is the way to go forward. Because
Absolutely. Well, we are Sector 39. You might find us on Facebook. I do have a website, but it's gone down at the moment. I've got to fix that. But let me just write this down. Sector 39, and yeah, I'm Stephen Jones. You're welcome to try and find me through social media, and I can show my email address as well. Actually, Sector 39 Permaculture, S39 Permaculture at gmail.com. And I put that in the chat if you want to see that. So you're welcome to reach out. And for sure, it's all about us working together. Okay, everyone. I'm going to say thank you very much for attending, and I will reflect on this series and will hopefully do something like this again in the not too distant future. I think it's very, very important to have open forums and discussions on these topics and to share our ideas. So once again, thank you, everyone, and bye for now.
Okay, bye.
Bye bye.
Bye-bye.